Welcome to Team 537's Robo Recap for the week of February 8th to the 13th. I'm your host, Sam Chapman. Week 5 of build season is well underway. Drivetrain parts are being manufactured, electrical boards are slowly shaping up, and the robot code is being developed. This week, our code team has been working on writing instructions for the portion of the game when the robot functions independent of live commands, known as the autonomous stage. The autonomous period is the first 15 seconds of each match, where the robot has to complete the desired objective without any help from the drivers. Code is also working on the basic code skeleton for this year's robot. Even with all of this underway, we managed to pry our code lead, Taylor Beinborn, away from his keyboard for a bit to talk to us.
Autonomous is the first 15 seconds of the match this year, and that is when the robot operates independently from the driver control. So the robot acts on pre-programmed instructions that code writes before competition, and then it will go and act out these instructions, and the drivers just watch the robot move. Our goal for this year's autonomous is eventually we'd like to have a 2-ball autonomous, where the robot starts with a preloaded boulder and then crosses a defense and then shoots the boulder into the high goal, and crosses back over the defense, picks up another boulder, recrosses, and shoots into the high goal again, for a total of 30 points. Code has been doing well. We tested our vision tracking software, and we had that working with the swerve style drivetrain, so we're hoping that that will transfer over well into the tank style drivetrain. And then also we have most of the robot functions coded out. We are now just waiting for the entire robot assembly in order to test these.
As code continues to develop new code and improve some already completed routines, the implementation of the commands would not be worth the effort each season without a place to store the code on the robot. This is one of the areas where our electrical team is key. The electrical CDT manages the brain of the robot and wires up the motors and sensors that are needed to help control it. As the new electrical board is being prototyped and finished, our electrical CDT lead, Kyle Herda, took some time to give us a brief update.
Some of the new parts for this year's electrical board is a smaller and more compact radio. And then we also have a vision processing board called the Jetson TK1 that helps process camera images that helps us track the robot's position in relation to the goals. Some of the constraints for this year's electrical board is that it needs to fit in a 12 by 12 by 13 inch space that needs to fit the battery in the front, compressor closer to the front to add as counterweight to the robot when we climb. We also need to fit in all of our components and 2 air tanks in that space as well. Right now, I think that it is going to go well. I am cautiously optimistic of how this will turn out. Right now, we have our team designing our electrical board in SolidWorks so we can get better visualization of where things will go. Almost all of the designs for it have been checked off. We just need to make some drawings for parts that mechanical needs to manufacture.
While our electrical CDT is quickly making progress, their work would not have a lot of significance to this year's robot without the help of our mechanical CDT making a frame that holds the electrical board and other important devices. This year's frame has been designed to have 5 wheels on each side, which our team has not done to this extent before. Working hard on leading the mechanical team to finishing these parts with the help of our new CNC mill is our mechanical lead, Colin Middlestat.
This year's drivetrain is the strongest drivetrain we've ever built. It's a 3-sim drivetrain, which will allow us to go over the defenses a lot faster than any previous drivetrain we've ever built. With the drivetrain this year, it's a 5-wheel drivetrain, so trying to keep all the wheels in line as well as the 2 rails that the wheels are attached to in line has been a real struggle. The CNC machine this year has helped us not only make parts faster, but also make them more accurate to help with alignment of wheels and other such things.
For the first season, our team has access to a CNC milling machine at school. The computer numerical control machine allows the team to create parts that may be too complicated to machine by hand, and also allows creating identical parts quickly. One of our mechanical team mentors took the time to step away from the station to give us a brief rundown of the capabilities and benefits the CNC has to offer us this year.
The CNC's really helped us. In fact, that the robot we're building this year is actually designed because we had the CNC. We would be building a vastly different robot if we were doing it on the manual machines like last year. There's many benefits with having the CNC. The major one that we came up with right away was we're able to do more complex parts in a more efficient manner. And one cool factor with the CNC is that we can get it working and walk away from it. It'll work all by itself. Well, I see Team 537 growing because we're going to be able to design robots different from this year forward. We're going to be able to do more complex things and engineer things differently, and we'll be able to produce a better robot.
Remember, the Team 537 Mini Regional is on February 21st at Hamilton High School in Sussex. There you can see more than a dozen robots in action and get a feel for how a real competition regional works. Many FRC teams from across Wisconsin will come to test and enhance their robots before ship day, February 23rd. Admission is free. Come, enjoy the fun from noon to 4 p.m. Everyone is invited. Thank you for joining us for this summary of the 5th week of build season. Tune in next week for the Team 537 Robo Recap.